Here we are back for another probability video, and my voice is still raspy, gravelly. It hasn't gotten better in the last few hours, and it's probably going to get worse. So far with our probability videos, we have talked about the three different methods for assigning probabilities, and we've talked about the the addition rules for assigning probabilities. In this video, we're going to talk about the multiplication rules. And just like with addition, there is the special rule of multiplication and the general rule of multiplication. You're probably guessing what the multiplication rules are all about. If you think about it a minute, I'll bet you come up with it. The addition rules, that's what we use when we want to know the probability of one or other events occurring. We add them. With the multiplication rules, those apply when we want to know the probability of one event and another event occurring simultaneously or in sequence. So let's go ahead and take a look at some more definition type looks of the multiplication rules. And determine the probability of one and another event occurring at the same time or sequentially. And here is what the formula looks like using standard probability notation. Get my keyboard out of the way. With the addition rule, we had the union symbol. With the multiplication rule, we have intersection. Probability of A intersection with B equals, or what's more commonly and probably more meaningful as far as way to say this, probability of A and B. Probability of A and B equals probability of A multiplied by the probability of B. Pretty simple, pretty straightforward. But it is a useful calculation, especially in some business areas, some areas of business, some different types of businesses. Just like the addition rule, the multiplication rule is applicable to more than two events. You're not limited to just two events. We've already talked about the concept of joint probability. Mention it again. This is the probability of two events occurring at the same time or sequentially. Another word for this is concurrence, or the events occur concurrently. The special rule of multiplication is only applicable for independent events. We talked about independent events at the very beginning of this unit in class. I don't have a video on it. But independent events are events whose probability is not affected by previous occurrences. The occurrence of one event does not affect the probability of the other event's occurrence. And as we get into some examples, we'll have one example where we use the general rule of multiplication, and it will remind you of what we mean by independence once we see that sample problem. But let's go ahead and look at a sample problem where we're using the special rule of multiplication. We have a twin-engine plane that's designed so it can fly on one engine. Both engines must fail for a crash to occur. What is the probability of both engines failing? Probability of one engine failure is 0.005. Probability of engine 2 failure is 0.005. They're identical engines. They have identical probabilities of failure. And like I said before in a previous example, we know this because of the engineering and the testing that goes into jet engines and other types of machinery. Before a jet engine is ever sold, the company that sells it already knows its probability of failure. So once those probability of failures are known and published, they could be used for determining risk. What is the risk of flying in a twin-engine airplane? Well, it's really minute, as we'll see here in just a second. Flying in a twin-engine plane is one of the safest things we can do, a lot safer than driving from Tahlequah to Tulsa on the highways. But let's go ahead and use the special rule of multiplication to solve this problem. And the notation has changed again. we have P sub F standing for probability of failure for event 1 and event 2. The events are the engine failures. Probability of failure, event 1 and event 2, equals the probability of failure of event 1 multiplied by the probability of failure of event 2. We plug in the 0.005 probabilities for each of the engines, multiply those together. We end up with a very, very low probability that both engines are going to fail at the same time and result in a problem for the aircraft and for those people who are traveling on the aircraft. And let's convert this into some more real-world numbers, get away from probabilities. This translates into one failure for every 25 million flights. Every 25 million flights, you could expect one failure of this type. Like I said before, aircraft are very safe. They're designed to have multiple fail-safes in place. If something goes wrong, there's another part of that aircraft that will kick in and correct for the component that failed or went wrong in some way. Now what we have here, we have a Venn diagram showing the overlap. We already know what Venn diagrams are, but I just want to show you this again. For those of you who are safety professionals getting ready for the CSP exams, you're probably going to see a problem like this on the CSP exam. And all you need to know is what I've outlined here. It should be a slam dunk on the CSP exam. Okay, let's look at another example. Teton tire knows the probability is 0.95 that the XB70 tire will last 60,000 miles before failure requiring replacement. A car owner purchases 4 XB70s. What is the probability that all 4 tires will last the full 60,000 miles? Got to have a drink of water. My raspiness is getting bad. I probably should edit that out of the video. I probably won't. Okay, but we have 4 tires. Each tire is expected to go 60,000 miles. What's the probability of all 4 tires going 60,000 miles? And here's an example where we do have multiple events. We have 4 events. We're going to multiply the probabilities for each of the 4 events. Different notation. Here we're looking for probability of success. The success being defined as the tires lasting 60,000 miles without failure. We have probability of event 1 multiplied by probability of event 2, by event 3, by event 4. Plug in the known probability values, 0.95 for each of the tires, for each of the events. Multiply those together, we end up with an 81% chance that all 4 tires are going to last 60,000 miles without a failure that requires replacement. Now, they may have a flat tire, but flats can be fixed. We're talking about blowout, sidewall, or other structural problems with the tire that is beyond repair. Over on the right, we have a more complex Venn diagram. But this Venn diagram really doesn't illustrate probability of success. That little black area of overlap, that's the probability of failure area. It's much smaller than the probability of success. But let's go ahead and look at the probability of failure. Now that we have probability of success, we can find probability of failure by subtracting probability of success from 1. Probability of success subtracted from 1, or 1.0. When we plug in the 0.8145 for our probability of success, subtract that from 1, we end up with about a 19% chance that at least one of these tires will fail before it reaches 60,000 miles. And that's the area in the Venn diagram that's shaded. If we drew a better Venn diagram for probability of success, there'd be more overlap between the 4 tires, and the area of overlap would be greater. This is another example of the complement rule that we talked about when we talked about the rules of addition. All right, one more example. But in this example, we're going to use the general rule of multiplication. Let me talk a little bit about the general rule of multiplication. With this rule, we're determining the probability of one and other events occurring at the same time or sequentially when the probability of one event is affected by the occurrence of the other event. When we have dependent events, that's when we need to use the general rule of multiplication. And here is the formula for the general rule of multiplication. Probability of A and B equals the probability of A multiplied by the probability of B given A. That's how you read that, B given A. And what that B given A means is that the probability of B is affected by the probability of A. And here's what I just said in writing. And what we're talking about here is conditional probability, which we've talked about before, where the probability of an event is conditional upon the occurrence of another event. And here's some more information. I think I've covered all of this about, I've covered all of that. Let's go ahead and look at an example. A golfer has 12 golf shirts in his closet. Suppose 9 of these shirts are white and the others are blue. He gets dressed in the dark, so he just grabs a shirt and puts it on. He plays golf 2 days in a row and does not return the shirts to the closet. What is the probability of that both shirts are white? And he goes in on day 1, grabs a shirt out of the closet without looking, grabs it blindly. It's dark, he can't see, just grabs a shirt. What's the probability of that first shirt being white? Then we want to pair that with the probability that on day 2 he does the same thing. What's the probability that he's going to pull another white shirt out of the closet with that blind draw, so to speak? And here's our formula, different notation. And the reason you see different notations quite often with probability is that a lot of times we'll use a letter or maybe even a short acronym to represent the focus variables we're working with or the focus events we're working with. This is the probability of white shirt 1 and white shirt 2 occurring sequentially. And this isn't concurrently, this is a sequential situation. So we have probability of white shirt 1 and white shirt 2 equals the probability of white shirt 1 multiplied by the probability of white shirt 2 given the occurrence of white shirt 1. If you're still lost, hopefully it'll clear up for you here. And I'm putting my probabilities in a little bit differently here to illustrate. The probability for white shirt 1 is 9 out of 12. There are 9 white shirts, 9 white shirts out of 12 shirts total. So on day 1, he's got a 9 out of 12 chance, or a 0.75 probability of picking out a white shirt. That white shirt he wore on day 1 goes into the laundry. It doesn't go back into the closet. So on day 2, he has 11 shirts, and 8 of those are white. So that's the probability of selecting or drawing out of the closet a white shirt on day 2. And all you do is add those probabilities together. Again, 9 out of 12, 0.75, 8 out of 11. We've got a nice little repeating decimal there. You can stop at 4 decimal places for our purposes with repeating decimals. But 0.7272, multiply those together. We end up with about a 55% chance that he's going to wear a white shirt on day 1 and a white shirt on day 2. And that's an example of the general rule of multiplication. So in this video, we talked about the rules of multiplication. More specifically, we talked about the special rule of multiplication and the general rule of multiplication. And these are the rules we use when we want to know the probability of two or more events occurring at the same time or sequentially. We use these, or this rule, when we want to know those types of probabilities. All right, I think I've said enough. If you have any questions, let me know. You've got my number.